Okay. Oh, bump the screen. Everything's shaking now. All right, here we go. Everyone get a paper? Yes? All right. So this is probably familiar to you, right? I'm pretty sure that this is stuff that you guys discussed back in Algebra 1, but we're going to cover this material again. So thank you. And just to, again, kind of make sure they were okay with graphing and stuff like that too, and rediscussing maybe some important topics about this, because students, don't always have a great time with things. So, for example, we'll refresh our memory here a little bit about slope. All right. So why don't you guys go ahead and do this. Number 1 and number 2, just calculate the slope there. I think you guys should be fine with that. So go ahead and calculate the slope. Let's make sure we're all okay with doing that. All right, and I'll do it too. Okay, and I even gave you the slope formula there, but remember that's something you'll need to know for the future. Remember, it's the difference, so it would be -2 minus 4, which would give you a -6 there. So just do these slopes real quick here. So those two, let's say we're talking about a line here, right? There's only one line that goes from this point to this point, right? So there's only one line that possibly exists. So should the slope from here to here be different than the slope from here to here? It should be, but it's on the same line, right? Right. One would be positive, one would be negative, but what happens when you do it the other direction? It just flip-flop, which one's positive, negative, so it's still overall. Okay, so it looks like everyone's got some stuff calculated. Good. Good. All right, so there's what you should have gotten for your slopes, right? 1, -4/5. 2, you could say either 2 over 1 or just the number 2, of course, is fine as well. Okay. Did anyone calculate the slopes without using the slope formula? Yeah, Preston, what'd you do? Yeah, just counted it, right? Jenny, did you just count too? Yeah, that's fine. You could have totally done that here. It's super easy, okay? It's up to you how you want to do it, right? You can remember there's multiple strategies, so whatever you're most comfortable with, that's fine. All right. So let's go back here. We have a little blank to fill in, right, for the next little piece. It says there that the slopes of parallel lines are equal or the same, okay? Equal or the same. So, yeah. So we want to remember that piece of information because we're going to be now asked to find the slope of each line and determine if the lines are parallel, which, of course, if we want to determine if the lines are parallel, we have to find the slope of each line there. Okay, we got to find the slope of each line. So I'm going to, we'll do one here. I mean, you can kind of like, when when it's nicely graphed like this, and a nice grid that's like very nice and square and stuff like that, you can kind of look at it, and we'll probably guess here. Number 3, what do we think is going to be the answer? They're probably parallel, right? They look pretty good. Number 4, what do you think is probably going to be the answer there? Not parallel, right? I mean, you can kind of tell that they're probably going to intersect somewhere up here, right? But let's just justify it, right? So we think we know the answer, but now we're going to justify it by doing the actual calculations here. Okay, so I'll do the slope of line AB. Now I'm going to do what Preston did. I'm just going to count it. So rise is 2, run is 4, which is then 1/2 if we simplify. Okay. And for CD, rise is 2, run is 4. So, oh my gosh, that's the same thing. What do you know? Okay, so we can state, using our symbols here, line AB is parallel to line CD. Okay, no English, right? We don't actually write out a sentence or anything like that. We can just use that little mathematical statement there. All right, let's go over here and just count these slopes too real quick. Let's see here. So let's do AB's slope. So slope of AB. Well, let's see, to get from A to B, I'm going to have to go down 1, 2, 3, 4, and then right 1, 2. So down 4 is a rise of -4 over 2, which simplifies to -2 when we simplify. And then the slope of CD, down 3, right 2. Okay, which doesn't really simplify, so we'll just leave it as -3/2. Okay, and so these two lines are not parallel. No surprises there, right? No surprises there. Okay, pretty straightforward stuff there. All right, let's move on here to the bottom then. So remember that equations of lines can be written as y equals mx plus b. Remember the other forms that you maybe talked about? Maybe you talked about standard form, which is ax plus by equals c. Okay, that's one way to write them. Also, point slope form is another way to write the equations of lines. But here's the most common, most useful form for us where we are in your math career right now. Okay, and where m equals the what? Slope. Very good. And b is the y-intercept. Thank you again. I like it when you say y-intercept and not just the intercept, because there's also x-intercept too, and b does not represent the x-intercept. Okay, number 5, right? Are the lines parallel? Yes. Why? Slopes the same. Parallel because slopes are equal. Okay? M equals -3 over 2. Okay? If you want to be even more precise here, right? We could also say I guess a more precise answer, perhaps a better answer would be parallel because the slopes are equal and the y-intercepts are different, right? Okay. Is that necessary? I don't know. But it's probably the better answer. It's probably the better answer. I would argue it's the better answer. Okay. Anyway. Number 6. Given the equations 3x minus 2y equals 12 and 6x plus 4y equals 16, are the lines parallel? No? Yes? Okay. So let's see. So Jackson, why do you say yes?
Well, because if you simplify the equation of 6x plus 4.
Okay, so run me through that real quick. We get 4y equals 16 minus 6x, I guess, right? And then,
I divided it by 2.
oh, you divide everything by 2 first. Oh, my bad. Okay, so so divided by 2, we get 3x plus 2y equals 8, like that. You divided both sides by 2?
Yeah.
Okay.
Minus 3x.
Then subtract 3x from both sides here. Okay, like that.
Yeah. And then for the other one, I just minus 3x and got -2y equals 12 minus 3.
So 12 minus 3x. Okay. And did you do any more to this one? No? Okay. So, and you're able to tell from here these are not going to be the same. So what are you looking at exactly to determine that?
The x, because that's the slope, -3x.
Okay, so, but they both say -3. So how are you saying that, but doesn't that mean that they're parallel?
Yeah,
Oh, you're saying they are parallel.
Yeah.
Gotcha. I see what you're saying. Okay, my mistake. Okay. What do we still need to do here, though? Aubrey, what do you say?
You still need to divide.
Right.
The
And so,
-2 and then just the 2.
right. And you see what's going to happen now because again, these are not quite in slope-intercept form. The y needs to be by itself. So we divide through by that -2. We're going to get a -6 and a +3/2 because it's -3 divided by -2. And then here when we divide both sides by 2, well, you can see now it's going to be 4 minus still 3/2x because it's divided by a +2. So no, or not parallel, we'll say, because the slopes are different. Okay, not parallel because the slopes are different. Okay, folks, if a question asks why, okay, sometimes our work is sufficient, right? Sometimes our work is sufficient to kind of show like why something is true, right? Like maybe you're given an equation and you're asked to show, why the answer is x = 3. Then you just solving the equation is fine. But here, just getting to this point and saying not parallel, it's probably a good idea to still then give an explanation because the slopes are different, right? Because this is not quite enough to kind of justify the answer. I mean, yes, you can see it there, right? And me as a math teacher, but it's important for you to, give that correct justification because the slopes are different. It's part of your analysis. Okay? So, thank you for that. Very good. All right. Now we're going to, of course, talk about perpendicular lines here on the back. So, the slopes of perpendicular lines are opposite reciprocals. Slopes of perpendicular lines are opposite reciprocals. So here I'll do like a little diagram. So if it's positive, it'll become, the other one will be negative, or if it's negative, it'll become positive. All right. If I look at that like a certain way, it looks like some sort of strange emoji or something like that. But anyway, all right. And then the reciprocal is if you flip the fraction, right? You flip the fraction. Okay. Now, again, number 7 and 8 were asked to find the slope of each line and determine whether or not the lines are perpendicular. But again, most of you guys, maybe your eyeballs are pretty good at looking at these things here. What do we think? What do we predict for 7? Is that going to be perpendicular? Yeah, it looks like it might be, right? What about number 8? No, okay. Another nice thing that you can do, you have a right angle right in front of you. It's the corner of your sheet of paper. So you can like literally like take the corner of your sheet of paper and like almost use it like it's a measurement tool and just see. Well, by golly, look at that. That right angle fits just right in there, right? Okay, but if we go over here and try and fit our right angle in there, doesn't look quite right, does it now? Okay, it doesn't quite fit. All right, so you can kind of use that to help you. All right, it's a tool available to you. See, same thing here. It's like, it doesn't quite look right. I can't quite fit that right angle in there. Okay, but anywhere in there, it does. So that's another little tool to help you. But let's, of course, do the official mathematical analysis here with numbers and things, too. Okay, so we'll do the slope of line AC. And then I'll also do the slope of line CD. Oops. That. Oops, I'm off the screen. Sorry about that. There we go. And I'll just count them again. Just count. So let's see here. To get from A to C, I'm going to have to go down 1, 2, 3, 4, and then over 1, 2. So -4 over 2, which is then -2 over 1. I'm going to leave it the fraction. I'm going to leave it as a fraction. -2 over 1. And then slope of CD, up 1, right 2, so 1 over 2. Okay. And so do our slopes strengthen our idea there that these were perpendicular? Does it confirm it? Yes, they're opposite. positive 1/2, negative 2 over 1, and then reciprocals, 1 over 2, 2 over 1. Okay? So remember we can use our symbol here, AC, line AC, perpendicular, it's the upside down capital T, to line CD. Okay, to line CD. Go ahead, take a minute, try number 8. Okay, do your analysis there, do our analysis there for number 8. Okay, do that analysis there for number 8. Take, like I said, a minute. Do that analysis there for number 8. Question, Bryn? Yes, go ahead. How to what? For not perpendicular, I would say, I don't think there is, but I could see potentially you using something like using this symbol and putting a slash through it kind of thing. Kind of like we do for not equal, you know what I mean? We use the equal sign and a slash through it. So you could do that. I don't know if that's the official thing, but I'd be okay with it. I would know what you're talking about at least. Okay. All right, what do we say here? Are they perpendicular? No, they're not. Okay. They are opposite. One's negative, one's positive, but they're not. The slopes are not also reciprocal to each other, so it results in something that's not perpendicular. Okay, not perpendicular there. The nice thing about proving things to be not true, right? So, for example, for perpendicular, the slopes have to be both opposite and reciprocals. If one of those two things fails, the whole thing is not perpendicular, right? Both must be true. So when you have a certain situation where you require a few things to be true simultaneously, as long as you can show that one of those things is not present, then the whole thing has to be false, right? So again, for perpendicular, you need two things to be present. The slopes need to be both opposite and reciprocals. If you can show that just one of those things is true, then the whole thing falls apart, and you can't say they're perpendicular. Okay. So here, in this situation, this scenario, we're given the fact that the slope of line A is given. So example number 9, slope of A is 5, and 10 is negative 2/3, so on and so forth. Then I want you to find the slope of line B, given that lines A and B are perpendicular. Given that lines A and B are perpendicular. So I'm going to call on some folks here, and we'll just have some of you all answer. Okay, some victim sticks here. So Avery, what do you say there for the first one? Negative 1/5. Okay, would be the perpendicular slope there. Very good. All right. How about Stephen? What do you say for number 10? Close. It would be 3 over 2, but we want to just make it positive. So let me, yes, just 3 over 2. And let me talk about that for a second because I see what you did. You saw that it was a negative 2 over a positive 3, and then you made it a negative 3 over a positive 2. The problem with that is that that would still make the fraction negative, right? This fraction, you can kind of think of it as this way. Okay? When you have a negative with the 2 like that, you can actually pull that negative out front and call it negative 2/3. You could also move the negative to the denominator and it would still be equal to the same thing. So this is the same as this, is the same as this. Okay? So make it positive. But I'm glad we were able to talk about that though too. Lucas, how about number 11 there? 5/3. Perpendicular slope should be
Negative 3 over 5.
negative 3 over 5, or 3 over negative 5. That would also work. 3 over negative 5 would also work there. Okay. And then Luke, number 12. What do you say? Positive 1, 8. Very good. Okay. Go ahead, try number 13 there on your own on the graph below. Draw lines AB and line CD and determine whether the lines intersect at a right angle. Okay, so go ahead and try that. I'll do it too. And then we'll come back and discuss it here. Slow at the beginning, slow at the beginning. Okay, so let's take a look here at what the graphs of these two lines look like. Okay. So walking around, I saw this. A few people got caught up here with some of the graphing of these points. Okay, so 4, 0 means we have an x-coordinate 4, y-coordinate 0. So there's where point C should be. Point D is point 0, 8. So 0 on the x-coordinate and x-axis, and up to 8 on the y-axis there. Okay? So if you plotted those points, if you plotted those points inaccurately, that's going to mess up your slope, at least if you were counting them. So there's maybe a flaw in the counting strategy, right? When you choose to count the slope, if you graph it incorrectly, then you're going to mess up obviously the counting. Okay? But of course, if you chose to use the formula to do slope, then it doesn't matter how you graph them, you can still, get it right, so to speak, if you, calculate your slope accurately. Okay? But this is what our graph should look like. And then there is our slope calculation, or counts, that's what I did. And then there's, a little statement there. Line AB is perpendicular to line CD, so they do intersect at a right angle, or a 90-degree angle. Okay? So be careful with that. Plotting those points and things. Okay? Want to be good with that. Question, Jenny?
I got the right answer, but I plotted C and D wrong, but I still got the same answer.
Mathemagic. Yeah.
I put D at 0.8, but on the Y, or on the X.
Oh, you put it like here?
Yeah, and then I put C on the Y.
Like here?
Yeah, and I still got the same answer.
You must have done at least two mistakes that cancel each other out somehow, and then allow it. So, yeah, because I'm assuming you didn't use the slope formula to find the slopes, did you? You just counted them, yeah. So you maybe miscounted your slope too, but then the two mistakes cancel each other out and allows you to get the right answer. So I will, on quizzes or tests, believe it or not, I will look at your work too to make sure your work supports your answer. So even if you get the right answer, I still might take a point or two off there because you got the right answer but in the wrong way. Okay, and I know that makes the students upset sometimes because you're all about trying to get the right answer, but if you get the right answer but the wrong way, that still shows you don't quite understand everything. So that's why I don't have a problem with taking points off. Okay. All right, I want to do just a few, maybe two other problems here, just on a separate sheet of paper, just to kind of make sure we're okay with writing the equations of the lines. Maybe three, just to see if we're doing okay too. So you want a separate sheet of paper here. Ooh, maybe more than that, actually, now that I'm thinking about it. Yeah, we'll see. We'll see how it goes here. Okay. See how it goes. Because I do want to get you time to work on your homework and stuff. All right, so now we've really hit on that parallel, perpendicular, slopes and things. I want to talk about writing equations of lines too. Okay? Again, it's something you did in Algebra 1. But hey, we're in geometry and we talk about lines too, so it's going to be important to be able to write those equations. All right, and so again, the key form that we're going to be shooting for here is going to be using that slope-intercept form to write the equation of a line. Okay, so scenario 1. Let's say we want to write the equation of a line given, and actually I'm going to do it this way, so that way I don't have to keep writing that. So we'll say write the equation of a line given, and for our first given information here, we're going to be told that m equals 4, and -5, 2 is on the line. Okay, so the slope of the line is 4, and -5, 2 is on the line. All right, so given that information, can I just say that, oh, okay, well, let's see here. This is slope-intercept form. My slope is 4, so I'll say y equals 4x, and b, which is my y-intercept, the y-coordinate there is 2. So the answer is y equals 4x plus 2. Can I say that? Why can't I do that? The slope's 4. B, my y-intercept, there's my y, 2. Why is that wrong? Daniel? Right. In fact, we not only do we know it's not that we don't know, we know that it is not. We know that it is not the y-intercept. It can't be if this coordinate, and how do we know that this coordinate is not the y-intercept, by the way? What gives it away?
X has to be 0.
X would have to be 0, right? Any point that's a y-intercept, it's a y-intercept because it's on the y-axis. Any point on the y-axis has an x coordinate 0. So this is definitely not my b value. Cannot be my b value. All right, so now we got to go back to square one. Well, no, because what was true about my linear equation here? Slope was still okay, so I can still put that 4x in there, but now I need to figure out, I'm not done, I gotta figure out what the b value is. Okay, I used my slope, but now I need to figure out what b is. How can we proceed from here then? What should we do? What can we do? What are we still able to do here? Avery?
What I did is I added 4 times 5 to 2 because the distance from -5 to 0 is 5, +5.
Yes, yes. And like what you're doing there is something we can even use the equation to do, right? This point is on the line. It must work in this linear equation. That means the 2 can go in for the y, the 4 can then be multiplied with that -5, and then you're going to add b to it, and you better get the 2, okay? Because that point is on the line. It's got to work in the equation. It must work. So we can use that to our advantage here. Multiply here. So you get 2 equals -20 plus b, and then add the 20 to both sides. We get b equals 22. And so then the equation is 4x plus 22. Okay. Key information there. Questions on that? Again, to write the equation of a line in slope-intercept form, you need to come up with the slope, you need to come up with the y-intercept. Here we were given the slope, we weren't given the y-intercept, but we could use that to again get the y-intercept and finally write the equation. All right, we'll do the same thing. Write the equation of a line given, given that -2, 7 and 4, -3 is on the line. Okay. What information are we not given in letter B that we were given in letter A? Okay. The slope. Uh-oh. We don't know the slope or the y-intercept. What are we supposed to do in this situation? Yeah, Preston? Right, we got 2 points that are on the line. Use the slope formula. So -3 minus 7, 4 minus -2, -10 over 6. Right, plus positive there, plus negative. And so that simplifies to -5 over 3. Okay, so now we got our slope. Now it's just like this previous problem where we had the slope and a point. Now we have a slope and 2 points to pick from. So I'm going to again write out y equals -5/3 x plus b. Which point should I use in my equation now to solve for b? Jackson. First one? Avery, what do you say?
I say the second one
Okay.
because the run is 3, so, and -3 plus 3 is 0, so it would be easiest.
Okay, okay. And really, long story short, you can use whichever point you want, right? Because both these points are on the line, so really it doesn't matter which point you use. We'll use the second one here. That -3, it's the y coordinate, so it goes in for the y. -5/3 times the 4. Fractions. Mr. Witt, I hate fractions. Geometry sucks enough with proofs. Now we got to do fractions too. Yes. Okay, so 4 times -5/3. Multiplying fractions, guys, is so easy, right? 4 is 4 over 1. So you just multiply the numerators, multiply the denominators. -5 times 4, -20. 3 times 1, 3. Now what should I do to both sides to solve for b? We're going to add 20/3. Okay? I need common denominators to add these. -3 is how many thirds? -9/3, right? And so it's -9 plus 20, which is 11. 11/3. So b is 11/3. And so our equation is y equals -5/3 x plus 11/3. Okay, yeah, Jen.
Is it okay if I multiply the 3 from the -20
I see what you're saying. So then you made this became like -9, -20, plus, did you do 3b there? No. So when you are in an equation, Jenny, and you want to do something like multiplying by 3, we can't like just isolate a particular thing and say we're going to multiply just this thing by 3. You have to multiply the sides, right? Each side gets multiplied by 3, including the b would get multiplied by 3 there. So you need to multiply the b by 3, and then it would work. Yeah, you would get your answer. It would be 11. It would be 3b equals 11. Did you get 11 for your answer?
Yeah.
Yeah, and it would be 3b equals 11. Divide that by 3. Boom, there's your 11 thirds, right? So it would work. It would work, but you have to multiply the b by 3 too. Great question. Any other questions on that? Okay. All right. Then I want to talk then incorporate now the parallel stuff to it. So write the equation of a line given. It is parallel to y equals -3/2. Oops, got ahead of myself. No, y equals -3/2 x plus 6. And -3/6 is on the line. Okay. So again, write the equation of the line given. It is parallel. Our line is parallel to this one that's given here. And our line also has the point -3/6 on it. Okay. How should we proceed from here? How can we proceed from here? What can we use to start things off? We're only given 1 point, so I can't calculate the slope using the slope formula. Madison?
Well, since we know that it's parallel to y equals -3/2 plus 6, we can do -3/2, and then don't know like the else.
The b. Right, so if our line is parallel to this one, we know that the slopes have to be the same. So if this slope is -3/2, our slope also has to be -3/2. And of course then we have to find the y-intercept. And how can we find the y-intercept? Plug in the point. Plug in the point. 6 in for y. -3 in for x. Okay, and fractions again, Mr. Witt. Yes, fractions again. Okay, -3/2 times -3/1, right? Multiply the numerators, multiply the denominators. We'll subtract 9/2 over. 6 is the same as 12/2, so 12/2 take away 9/2 is b, which is just 3/2. So y equals -3/2 x plus positive 3/2. Okay. One more little twist. What if instead of parallel, what if we said perpendicular? How do we have to change what we did there? Instead of saying -3/2 is our slope, Maddie. Good. Y equals 2/3 x plus. Could I use the same y-intercept that we calculated from before? Would it be the same y-intercept? Most likely not. Okay, let's check, but most likely it will not be the case because it's a different kind of line now. The slope's different, and so we're going to end up hitting the y-axis in a different place now. Let's just check to make sure, though. So we'll plug 6 in for y. We'll plug the -3 in for the x. 2/3 times -3, or -3 over 1. -3 times 2, -6 over 3. Oh, thank goodness, Mr. Whitmire, it simplifies to -2 plus b. Add the 2 to both sides, we get b equals, 8. So we get a different equation here, completely. Okay, completely. All right. So, questions on any of that? All right. Remaining time is yours. Your homework is on Google Classroom, okay? Please only do the circled problems on the paper there, okay? So on Google Classroom, You'll pull it up, okay, and you'll see that there are problems that are circled. It's a front and a back.